Alright, today's lesson is on completing the square. And can you see this okay over here? Alright, so when you use the quadratic formula, do you know what the point is? Okay, so quadratic equations have like a general form that looks like this. No. So this is not the quadratic formula, but it does the same thing as a quadratic formula. So you have the general form of a quadratic equation is like this. Y equals ax squared plus bx plus c. Got that? All right, so let me see you make up your own quadratic equation. Make it up. What would it look like? Yeah. So y equals 12x squared plus 7x plus 69. All right. Hold on a second. All right, if I graph the equation that you made up, what do you think it's going to look like? Yes, it's going to be a parabola, a u, x to the power of 2 plus 7x plus 69. And I got to zoom out so you can kind of see it way up there. See it? All right. And does this parabola that you designed here, does it cross the x-axis? No. Yeah. I'm going to go ahead and bring this down a little bit and maybe say like, what happens if I do like minus 10? Oh, there. Now it's over there like that. Okay. What if I change this over here? Well, that's okay. We'll leave it like that. Okay. So these values right here, do you know what they're called? That negative 1.25 and that 0 and that 0.667 and that 0. You know these guys? What are those guys called? Well, there's something very special about these coordinates. Yes, but there's something else that's even more special. It's about what they're called. They're called the x-intercepts. So they are, let me go back over here. They are the points where this parabola intersects the x-axis. You with me? All right. So I'm going to make an easier one, a less complicated one before we start this lesson. So I'm going to go, let's see. I'm going to kind of work backwards to design it. So there. Okay, so the one that I made up, this one down here, it's y equals x squared plus 2x minus 15. Okay, so what do you think the x-intercepts are on this one? It's kind of hard to tell, actually. You can guess. It's super hard to tell. What are the x-intercepts for this? So this is the equation right here. So here's the equation. That's weird. Hold on. Okay, so this equation right here on the right. So y equals x squared plus 2x minus 15. All right, that graph is the one that's right here. That's this graph right here. So I'm going to copy this graph. All right, and these guys right here, what are they called? This one and this one. X-intercepts. Why is it called the x-intercept? So this is, well, because this is where the x-axis is crossing the parabola. Crossing it right there, crossing it right there. Okay, so those are called the x-intercepts. So whenever you see like a quadratic equation like this, and it says solve, what they're really saying is find the x-intercepts. So you're solving for the x-intercepts. So they could say like find the x-intercepts. They could say solve. or they could say, find the roots, or they could say, what are the solutions? It's 4 different ways of saying the same exact thing. You follow? Okay. Now, one way, which is the absolute easiest way, but it doesn't always work, is to factor. All right, so if you want to find the x-intercepts from this equation right here, let's just go ahead and factor it. So if we were to factor it, how would you start this factor problem? The one on top. So how would you factor this? So bookshelf, what goes on top of the bookshelf? Well, you're absolutely doing complete square, but you have to understand how it fits into everything. Yeah. No, you do bookshelf to solve something that would give you the same answer as completing the square. But completing the square lets you solve much more complicated ones. All right, so what we're going to do is we're going to solve this equation 3 different ways. And one of them is going to be completing the square way. So we'll solve this equation right here. So how do you go ahead and factor this thing? Okay, so 15 up here, 5 and 3, all right. So you're saying positive 5 and negative 3. All right, so what do I put in here? Great, x plus 5 and x minus 3. And we know it's positive 5 anyway, because since the middle number is positive, the bigger number is like the stronger dominant number. It's going to have the same sign as the middle number. All right, cool. So then you go over here and you set this equal to 0. And you're going to find the roots or the x-intercepts or the solutions, or you're going to solve. So, and what would those answers be? So what we're going to do is we're going to find these values right here and right here. We're going to find where they are on the x-axis. And we've almost done doing that. All you want to do is you just want to cover up one side. What did you say? Negative 5 and 3. Yeah. How'd you do it? So you could do it one of 2 ways, right? You can just go like this, and then just whatever this sign is, you just do the opposite. You follow? Oh, you didn't say yeah, that's right. That's what I did. You just stared at me, or stared. All right. So, or you could do it this way. Either way, right? Okay. All right. So negative 5 and positive 3. And if we look over here, we now know what this coordinate is. What is this coordinate on the? I'll write it over here. So x equals negative 5 and x equals positive 3. All right. So what's this coordinate right here? And you're going to get it from one of these guys. What's this coordinate? What is this? What is that point right there? You don't have to. You gave it to me already. Okay, so it's 3, comma. What's a coordinate? Like this coordinate here would be like 20, comma 60. Well, it's on the x-axis. How high up do you go? There's no 0. It's on the axis. All right, then over here, what's this one going to be? Negative 5, comma 0. Okay, So what did we just accomplish with factoring? Of, well, not specifically, we found the coordinates of the what? X-intercepts. All right, that's one way. So let's put that over here. Not yet. We're getting to that. You have to understand what it's for. So that if you don't understand what it's for, then you won't know how to use it. Okay. We'll just squish that over there. Put that over there. All right. And the original equation that we used for completing the square was, for like this solving, was y equals x squared plus 2x minus 15. Okay. Now we're going to use a quadratic formula. What's a quadratic formula? What's a quadratic formula? Okay. It's on, if you forget, it's on your screensaver. Okay, it's x equals. Wait. You had it right the first time. Negative b. Okay, Mm-hmm. We're going to put that over here, 4ac. 2 eggs, got that. I'm going to put it, I said b squared, and then minus. That's all it's missing. That's pretty good. All right. So let's use our quadratic formula, because you know what the quadratic formula does? What does the quadratic formula allow you to figure out? I already mentioned it. What does it allow you to figure out? Boom. Allows you to figure out the x-intercepts. So if you have a quadratic equation, like one of these guys, and it says solve, you could actually do the quadratic formula in every single one of these problems, and it'll work. All right, so let's do that. So we're going to use this equation right here, this one right here, though. So we're going to do x equals. All right, let's go. Here's a general, if you can see it right here. -2, okay. Plus or minus square root. All right, so 2 squared, b squared, minus 4. Mm-hmm. So 4a, -15 all over 2 times 1. Okay. And when you study, I can't emphasize enough, use your graphing calculator. Super, super, super important. Take it to school with you. Okay, so here we go. Boom. Graphing calculator coming up. 5, 4, 3, 2, 1. Okay. There it is. All right. So let's figure this out. Tell me what to punch in. All right, so first thing, best way, easiest way to do this, so you don't mess up, is this part right here. Type it in your calculator exactly like you see it. That's mess up free way of doing it. So just go 2 squared minus 4, and we'll just do the 1 just to get in the habit. And then like that. Is there anything different from how this is to how this is right here? Nope. All right, so then we get that answer. There it is, 64. Okay, so then what do I write? Yeah. So x equals -2 plus or minus the square root of 64, and then over 2, because 2 times 1 is 2, and then correct. Let me just move this over here somewhere. Wait, 3, 0, and -5, 0. Okay. You said x equals -2 plus or minus the square root of, no, not the square root, just 8, right? 8, okay, over 2. All right, and we split it up, bam, bam, and then we're going to get x equals -2 what? Plus 8 over 2. X equals 8. So wait, what does the top equal? What does the top equal? It's well, first you have to work out this part. If it's opposite sign, subtract them, take the sign of the bigger number. 6. All right, 6 divided by 2? 3. All right, then over here we have x equals, what did you say? No. Minus 8 over 2. All right, what do we get on the top? No calculator? Cool. So x equals -5. Do these numbers look at all familiar to you? Why? Uh-huh. So what does the quadratic formula let you figure out? Good. The x-intercepts, which is exactly what factoring did, right? But quadratic formula will let you solve for things that are unfactorable. So quadratic formula is like the most powerful one, but also super annoying to use. What's that? What do you mean labeling them? Am I labeling them? Oh, you want me to label them, as I said? Sure. Oh, I see. Oh, we're critics, are we? Okay, let's see here. All right. There's that. All right, so you can factor. Don't worry, don't worry. I got this. No, hold on. This is going to happen. Okay, so factor. And the other way of doing things is the quadratic formula. I'll just stay consistent. Okay, and then the third way, the moment we've all been waiting for. The moment, the time in the video that you're actually going to start playing it. Right here. What is this method? The third way of doing the exact same thing. Completing the square. That is an awesome question. You're asking a great question. Because there are harder problems that involve circles and vertex forms of parabolas and stuff that involve you actually knowing how to complete the square. So you're not actually going to complete the square to find the zeros. You're going to complete the square to do like circle graph problems and other type of things. So it's like a foundational skill to do harder problems. All right. So completing the square. That's the other one. end up moving this thing again. All right, so we're gonna do the same exact problem, but we're gonna complete the square. And there's two types of completing the square problems. There's easy ones and hard ones. And if you look at this over here, wait, are your eyes open? They are. There they are. All right, so the easiest type of completing the square problem is this one. The reason why I know, actually, yeah, that's the easiest one. Yeah, there's no like 4 here. It's harder when there's a number right there. Okay, so completing the square. So we're going to start with this, which is x squared plus 2x minus 15. All right, and we're going to set that equal to 0. And in order to complete the square, you're going to have to move this last number, this c right here. This is considered c. You want it over here. All right, so I'll rewrite. So x squared plus 2x minus 15 equals 0. Then you go plus 15, plus 15. All right, so x squared plus 2x equals 15. Yeah, with me? Okay. Next thing you're going to do is you want to know this little formula, which is a little thought bubble. You want to know b over 2 squared. Okay, so what number is our b number? 2. All right, so we'll just kind of go over here and do that over here. So our b number is 2. All right, and then we're going to cut it in half. This is the part you have to, like in the quadratic formula, you have to memorize that massive formula. For completing the square, you have to know this thing. Okay, so it's going to be 2 over what? Over 2 and then squared. All right, I just think of it as whatever number is here, cut it in half and then square it. All right, so what is 2 over 2 squared? Well, 2 over 2 is 1, right? And you square it, it's 1. Okay, so then what you're going to do is before you start anything, you're going to go plus blank. And I should have already had done that. And then plus blank. So whenever you complete the square, after you move this thing over here, go plus blank and then plus blank. Then this number that you figured out right here, it goes right here, like that. And in math, when you have equations, are you allowed to just throw numbers magically in there? Why not? Well, you said that's not how life works, but then that is true. But let's say you have like this, right? Let's say we have 5 plus 5 equals 6 plus 4. Do you agree that the left equals the right? Can I just magically throw a 1 in there? Why not? Or what's the better answer? They don't equal, right? So in order, if I really want to throw 1 here, what must I do over here? You gotta throw 1 over here. So I really want to throw 1 over here, so I absolutely have to throw 1 over here. So when you complete the square, you'll always want to do plus blank, because I have often, when I've completed the square, forgotten this part, and the whole thing will be wrong. So you always want to, whatever you put here, you put over here. You with me? Okay, so now, what you've done is you've created like a quadratic expression that is super easy to factor. All right? So like, think of the numbers like 81 and 36 and 100 and 25. What do they all have in common? Yes, they are all numbers. You're on recording saying that. But what else do they have in common? Huh? Okay, watch this. Bam, 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 bam. What about it? Yeah, you can take the square root of all of them, and it works beautifully with no decimals, right? So you go like there, you go like there, you go like there. So all of these numbers are considered perfect squares because you can take the square root of all of them. All right, so what you've done with like this polynomial thing is you've created a perfect square. You've created a number as friendly as these guys in algebra land. So when you factor it, it's actually going to be something that's like this. Just like how 25 is the same thing as 5 squared. Okay? So, but before we do that, we're just going to do it the other way. So we're going to go like this, and we're going to go like this, and we're going to go like this, and we're going to go like this. And so our goal is to factor this guy right here. Okay? But this is actually the easiest factor problem in the world. Uh-huh. And you never have to bookshelf it, and it's super easy because this will always be x. The last number will always be the square root of this number. So in this case, it's just 1. And it gets really hard. Well, like this number sometimes will end up being like 49 over 9, like right here. But even then, it's not that hard because all you do is you just go like this. You see? So then over here, huh? No, it'll always be very easy to factor. You'll never, every single time, because this little trick that we did by throwing that 1 on both sides makes this very easy to factor. No, all of these that we're going to do will be a piece of cake to factor. Okay? So all you have to do is you just have to know like the square root of this number, which is 1. And then what you want to do is you want to take this sign, not the second one, this one. You want to put it here and you want to put it here. You're done. So you take, if I take the original one that's up here, x squared plus 2x plus 1. Well, do you know what the square root of x squared is? X, right? So that goes right there and right there. Right there and right there. And you know what the square root of 1 is? 1. So that goes right there and right there, right there and right there. I left it out. And then you just take, which sign? The first sign or the second sign? Well, no, it does because you might end up with this and want some problems. You always want this sign. This one. That one goes twice. That one and that one. All right. Now that we know that, we're not going to do it like this. So rewind. What are we going to do? Yeah, but look, you said it wrong. So look. Yeah, but you're right. You're going to do that. Then you're going to go there, and then x plus what? No, 1. Okay. So we have all of that, right? And then over here, you're going to show equals. And then you add these up over here. What do you get? No, you're going to add these up right there. 16. All right, so equals 16. Next thing you're going to do, by the way, completing the square is super annoying and it's kind of a hassle. All right, so what you're going to do now is you're going to go root, and then you're going to go, while you're watching, plus or minus root. All right, so what do? You go root, and then you go plus or minus root. What do? What do we do? Root and plus or minus root. Root plus or minus root. All right. All right, what's this root going to do to this 2 right there? What's the root going to do to the 2? If the root, well, yeah, but so what do I write? Yeah, so the root's going to kill the 2, the power. So you're going to get x plus 1. All right, I'll take the parentheses away. Equals 4. Good. All right, so then we're going to go ahead and subtract 2 from both sides. And when you put the, sorry, that was just to make sure you're paying attention. Subtract 1 from both sides. And when you put the new one in, it goes before the plus or minus. It goes here. So then this swipes here. Bam! And you're going to get x equals -1 plus or minus 4. Then we're going to split there and there. And you're going to get, let's just write them before we do the math. What's the first one going to be? And then x equals -4. All right, and what do we get right here with no calculator? Right here, so they have opposite signs. So 3, yeah. So subtract, then take the sign of a bigger number, 3. And then over here, get x equals -5. Cool. And do these numbers... She said that she's surprised that these are the same numbers. Even though she knows it going in, then she forgets. Okay, 1, 2, 3, 4, 5. -5. 1, 2, 3. So what do we just solve for? X-intercepts. Great. Good. And by the way, I didn't tell you this, but the reason why we know it's a happy face and not a sad face is because this number here is positive. All right, so we know that the parabola, the u, goes up like this. It doesn't go like this. All right? So there's our parabola, and we found these answers by completing the square. All right, so we're going to do 2 more. I'm going to turn you loose on completing the square. All right, so um, actually, I already did the medium one. So look, the easiest possible one is this one here. Look, and the reason why it's easy is because they already moved the 25 to the other side. See? It's been done for you. All right, so this one here, what's the first step you have to do? What has to be done first right here? Oh yeah, add 39 to the other side. All right, cool. Now the hard one. We're going to do the hard one. Actually, let's do, since the one that we did was like the easiest possibility because there was a 1 there, let's try this middle one here. So, yeah. R squared minus 4r minus 39 equals 0. So, well, let's use this skill and apply it on the hard one. So you have 2 examples of the easy, 1 on the hard. R squared minus 4r minus 39. I know, which is after this one. R squared minus 4r minus 39. All right, so equals 0. All right, what's the first thing we're going to do? Add 39. Add 39. Add 39. Okay, so we're going to r squared. What do I write? Equals 39. Then what do we do? No bookshelf business. You're going to, yep, but before you do that, you always want to go plus blank plus blank. Why do we do that? So you don't forget to do the second part of it. Okay, now we do the b over 2 square business. So we're going to go over here. We're going to be like, all right, we got to do b over 2 squared, which means you get the middle number, you cut it in half, and you square it. And then, you get the middle number. So this the middle number here. So, boop, boop, boop. You cut 4 because 4 is the middle number. Okay. Yeah, 4. Okay, so 4, it's actually negative 4, right? But do we really need to know that? Do we care that it's negative? Do you know why we don't care that it's negative? It has to do with this guy right here. Why? Because when you square, what happens when you square a negative number? Yeah. So no matter what, it's going to end up being positive. So it doesn't matter that it's negative. It complicates matters, actually. All right, so you get this 4, and all right, cut it in half. So we're going to go 4 over 2 like that, and then we're going to square it. All right, so what's 4 over 2? What's 4 over 2? No, 4 over 2 is not 4. The, yes, but I asked you what 4 over 2 is. I asked you what the final answer is. What's 4 over 2? And you square it, what do you get? All right, so you get 4. So now what do I do with this 4? Like that? Like that? We good? We done? Why not? Yes, because we can't just magically throw 4s in like that. We're not crazy. All right, so we have that. Now what do we do? R squared minus 4R plus 4 equals 43. Okay. Now what? Now what? No, 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 no. So remember, we've created a perfect square. We've created the easiest possible problem to ever factor. So we're going to go right here, and we're going to go bam, bam, squared. And this will go in there. Okay. What did you say? What did you say? Okay, remember, you always take the first sign. All right, R, yep, R minus, and then the square root of whatever's right here. Not the middle one, but the last one. R minus 2, okay, equals 43. Now what do we do? Root, and what do I put on this side? Plus or minus, and you remember the plus or minus? I'm impressed by that. I thought you'd forget that. Plus or minus. All right, and then what happens on the left? R minus 2 equals plus or minus the square root of 43. Now, IXL for this lesson wants everything taken to decimal, which is super annoying, by the way. Okay, so now what do we do? Okay, go plus 2, go plus 2, go plus 2. All right, so you're going to get R equals 2 plus or minus the square root of 43. Well, that would be the answer on the SAT. That'd be on the answer on any math class. But IXL wants you to type it in as a decimal. So you have to go over here. Bam. And if you look at their instructions, they say they want round to the nearest hundredths place. Do you know where the hundredths place is? It's two numbers after the decimal. All right, so let's go ahead and just take the square root of 14. So of 43. All right, so that's 6.5574. I'll write all of that down. 6.55774. And then we have R equals 2 plus or minus that. Okay, we're going to get our two answers. I can do the first one in my head. What's the 2 plus that going to be? 2, like, so when you're done with your answer, it's going to end right here. But don't worry about rounding it now. So just, okay, so like, we're going to just add this. So go 2 plus, and then your calculator, just go up, bam, go enter, bring that down, enter. So we added those together. 8.5574. Then for the other one, go back up, go here, and you're going to go 2 minus, let's get that old answer. Doot, 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 right there. And what do we have? Yep, negative 4.5574. All right, so we know that our answer, because we're going to the hundredths place, needs to cut off here, needs to cut off here. All right, so we go and we look at the one to the right of it, look at the one to the right of it. All right, is that 5 or higher, round up, or below 5, stay still? All right, so what's the first answer going to be? Okay, those are the two answers. Got it? Ready for the hard one? Okay, but there's something I got to tell you. I don't know if it's going to come up in the hard one, but there's just one more thing that you have to be aware of. When you're, if you're factoring something like, let's say it's like, you know how, like let's say you have like r squared, and then there's like something there, and then it's got plus 49 over 9, right? And then you have to do your b squared over 2. I'm sorry, your b over 2 squared. Sorry, it would be your, just kidding. You want to do your, you want to factor it, so you want to go like this. Okay? This looks like it's really hard. I need you watching. But this is actually really, still really easy to factor. Okay, so what number goes here first of all? What goes here? I'll just put like a heart, because I don't really know what would go there. But I'll go like that. There. So what goes, r goes here, right? What sign goes here? Plus, is it because of the first plus or the second plus? First plus, and then what's the last number? And it looks scary because it's a fraction, but it's actually really easy. Exactly. 7/3. All you do is just the root, and whatever that is goes there. Okay? So it's 7/3. You're going to what? All right, I'm going to pause, and we're going to do the hard one, and then your turn you loose. Okay, so this is the one here. Okay, so we have 4q squared plus 56q minus 76 equals 0. Okay, what makes this problem annoying? Right, so one way you can do this is you can, and it'll work on this one, and then you might want to, you might need to text me if it doesn't work anymore. But for this one, you can try this. Divide it by 4, divide it by 4, divide it by 4, divide it by 4. Like that. But I think it's going to work for all of IXLs. So I think you're okay. So I think that's actually, all right. Okay, let's just do it the regular way. Let's just do it the regular way. But that way, by the way, would immediately turn this problem into an easy problem. But okay, here we go. So what you want to do, what's the first thing you can do anyway? What's wrong with this 76? Well, from your completing the square protocol, yeah, you have to move it to the other side. So let's do that. Let's go plus 76, plus 76. Okay. Then you wipe this out over here, and then watch what we have. We have 4q squared plus 56q, and then we have 76. What else do we do? Good. Plus blank, plus blank. Okay. Now, before you do anything, you got to pull this number out of the left side of the equation. So you factor it out. So you go like that, and then you end up with q squared plus what? All right, tell me what that is. But it's the other way from what you just said. Okay, so 14q. All right, and then we have plus blank, close parentheses, equals 76 plus blank. You with me? Okay, What's the next step? Just from normal business. Good. You're going to do b over 2 squared. So b over 2 squared. So what do we get? We get 14 over 2 squared. And what's 14 over 2? No, that's too much work. What's half of 14? What's 7 squared? Okay, 49. So that's 49. Okay, so we're going to put a 49 here. And what do we put over here? But before you answer that question, let me just tell you that over the 13 years or so that I've been tutoring, I think only one person has ever gotten the answer to this question right. What would I put over here? Nope. Because you know how normally we put, like, I would say, like, oh, you can't just magically put a 49 over here. We didn't really put a 49 over there. You actually put a different number over there. You put 4 times 49 over there. It's just in disguise. You get it? So you put 196 on this side. So over here it gets 196. That's the hard part about this problem. Is that one step. What? All right. So if we look at what we did before. So if we go up, go up, go up, go up, right here, right? We put a 4 right here. I'm like, well, you can't just magically put a 4. So then we put a 4 over here, right? But what we did was we pulled out a number to make things easier for us. But that number is supposed to be multiplied by everything here. So when you drop a 49, yes. You get it? Okay. All right. So now we still have this 4 on the outside. And I'll just rewrite the whole thing. So then we got q squared plus 14q plus 49 equals whatever 76 plus 196 is. So 76 plus 196, which is 272. Okay. Now it's business as usual. Just keep the 4 out here the whole time. So we're going to go like that. And then we're going to go bam, bam, and then bam, and then like this. So we're going to factor this, but we've just created the easiest problem in the world to factor, and that goes here. So how do we factor q squared plus 14q plus 49? What'd you say? Q, take the sign right here, q plus 7. This is the ugliest q ever. Okay, so, all right, cool. Now, what you want to do is you want to divide both sides by 4. So, bam, bam. Hey, I got a question for you. If you wanted to, not that you would ever do that for this problem, but if you wanted to, could you divide both sides by q and wipe out your q? Nope, that's not why. Because it's not being multiplied on the outside here, so you're breaking an algebra rule. So like if I had an m and then I had like a q plus 7 equals 2, can I divide by m if I wanted to? You can. This is a very confusing thing in algebra. So look, look, look. You watching? You're not watching. Okay. So you're allowed to do that, but you're not allowed to do this. So you're not allowed to be like, cannot do this. Why not? Well, I would be really concerned about this because this is what you're going to get on the SAT. You're going to get this. I did tell you why, but every time I tell you why, your eyes look downward, and then you say, uh-huh. Okay, look. If you go like this, and you go like this, and I say, can you please get V by itself, how would you do it? V, like victory. Yes, you divide the M, and that would be correct. You can do that. Okay, now watch. If I said, please get V by itself, I'll put a different letter here. Get V by itself. And I know you don't think this is useful. This is extremely useful. Okay. Okay, so get V by itself. So what you want to do is you want to think of this entire thing as the letter M. All right, so how do you get V by itself? I mean, how do you get, well, yeah, how do you get rid of V? You can get rid of V. How do you get rid of V? Get rid of V. Okay, get P plus 2 by itself. You can divide V. You can go like this. Okay, because what you cannot do is you cannot do this. No, there's no obviously. No, you got this wrong already. And you're not the only one. Like half of algebra people get this wrong. This is a very common mistake. I absolutely 100% know that you don't know this. So Q times V plus 2 equals 7. So then if I said, hey, solve for V, look, how do you solve? I just want you to do well in this test. How do you solve for V? How do you get V by itself? Okay. Well, no, it's multiplication here, so you have to divide. Okay. Okay, you can do that. That'll work. V equals, but what if it was all under one fraction? Like, what if these are combined answers? That's okay. No, it's okay. It's okay. All right. I know, it's fine. Okay. I'm just saying there's a hole in your knowledge here. And it's a hole, like a lot of people have this hole in their knowledge. Okay? And so there's different things, like a lot of people think, oh, I'm going to do that. And earlier you said you can do that. And then I told you you can't do that. And then in retrospect you say, oh yeah, well I know you can't do that. But you can't do that because you're adding right there. But then what the heck allows you to divide it by p? Why can you divide it by p? It's being multiplied. Well then what about this? What about I just want you to do well. This is all in the SAT. All in the SAT. Tell me the different ways you can manipulate this. But can you actually divide by something? If you wanted to. What would the whole thing be? Like all the way across or one of them? Well, like are you saying divide by this, like m plus p and then like q plus 2? Yes. That's what you can do. You absolutely can do that. You can do this, look. Because this right here, you can treat it as like a letter. Like m plus p can be treated like one letter, like the letter x. So if you had like the letter x and you had times 3 and it was over 7, or what's a better example? Oh, I know. Like this. W equals 10. And you want it w by itself, what can you do? If you want w by itself, what can you do? Divide by x, which is just like this. This entire package functions like an x. Okay. I remember having trouble with this in college. All right, so back to this. All right, so we're going to divide by 4. Watch. Divide by 4. Divide by 4. Gone. All right, so we have 272 divided by 4, which is 68. So now we have q plus 7 squared equals 68. Right, now what? You mean take the square root? All right, take the square root, and then go on this side, what do we do? Plus or minus the square root. All right, and what do we get on the left? Cube plus 7, and then what do we get on the right? Plus or minus the square root of 68. All right, so then we get our calculators, because that's how Excel wants us to do it. All right, and we do the square root of 68, which is 8.246. So you have q plus 7 equals 8.246. Okay, now what do I do? Or plus and minus? Minus 7, minus 7. So then I get q equals what? Okay, 1.246. And what's the other one? Positive or negative? Negative 15.246. Okay. And if we type these in, we're going to get them wrong in IXL because it's not rounded right. So how many numbers after a decimal are we rounding it to? We're rounding it to right here and to right here. All right, so what do I write down for this one? 1.25. And then the other one, negative 15.25. Do you get it? Any questions on the hard version? All right. Try it. Your turn.